Alrighty, so right now we're going to be doing page number 3, problem number 1 on exam number 2, which is in relation to derivatives, but specifically graphing derivatives. So in this problem, we're asked to graph the first and second derivative of graph of f of t based on what we have. So, and then eventually in part B, we're going to be asked to find the intervals that are considered to be decreasing, concave up, and then slowing down. So let's start off with graphing. So looking at f of t right here, and we're trying to graph the first derivative of f of t. So in this case, when graphing the derivative, we want to look first at the x-intercepts, which will occur on the f prime of t at the points where the peaks occur. So x-ints can be represented by these 2 points right here, and then the new peaks that we'll have on f prime of t can be represented by these 2 points right here. Okay, so looking at that, we also have to look at the way in which the starting curves transverse. So given that the curve here starts negative or starts positive or has a positive slope, it means that we'll start off on the positive side, and then given that this end is also positive, has a positive slope, we'll end up in the positive quadrants over here. So we have the two ends, and now let's try to find the x-intercepts. So the x-intercepts are going to be at the 2 peak points right here. So we're going to be at x equals -6 and x equals 2. So we can just mark those 2 right here accordingly. And then peaks. So the new peaks, they're represented by the change, the dramatic change in slope, or the change of the rate of change in the f of t graph. So in this case, we have 2 points that can represent the change in the slope. So we have 1 point right here, which is around -2, and we have 1 point here, which is around x equals to 0. So these 2 points will represent the new peaks. So we can just mark those accordingly. And given that both change of slopes are negative, because the slopes are negative, so we have negative over here, that means that they're both going to be in the negative quadrants because the rate of change is negative. So we have a peak at around 2, which is going to be right here, and have a peak at around 0. It's going to be around here, give or take. So if we connect the dots, we should have something like this that looks more like a tooth. If I can just maybe correct it here a little bit, just to make it easier to understand. It should look like a tooth. So right here we have the new peaks. So we have the new peaks for the first derivative of f of t, which can be shown right here. And then now we have the new x-intercepts right here, which can be characterized by the initial peaks in f of t. So we have we can just like label the new x ints, add these 2 points as well too, just like that. And then that's how you have the graph of f of t. And now graphing the graph of the second derivative of f of t, we could just like look at the first derivative of f of t, the graph, in order to gauge what the last graph will look like. So given that the starting curve here is has a negative slope, this means that we'll start on the negative side, or on the negative quadrants. And given that the end curve, or that goes to infinity, is positive, has a positive slope, it means that we'll have a positive ending right here. So, like I mentioned before, we gotta look at the peaks in order to find the x-intercepts. So the x-intercepts are gonna be at around x equals -2, give or take, like at around this point, and then at around x equal to 0. And then the new peaks are going to be at the change in slope for f prime of t. So the change in x, or the change in slope, they occur right here at around these 2 points. And this is give or take like x equals -2, and then this is give or take x equals like negative half, or -0.5. So but the key is here that given where we can just like label the new peaks first. So I have a new peak right here, give or take. Because the new peak will be right here, because you have the change in slope right here, but it's a positive change, or the slope is positive. And given that the slope is positive, it means that the new peak is going to be in the positive quadrants. Whereas on the other side, or on the other change in slope, it's a negative change in slope. So that means that this is going to be in the negative quadrants. So we have the new points right here. Just utilizing those, we can graph the new, or the second derivative of f of t. So we can just connect them together like that, and like that. It's not exactly, didn't exactly match the positive endpoint, but that is okay, because as long as we have the general idea of the graph, that's how it should look like. So something like this should do for this kind of problem. Or let me just like correct it real quick, just like that. Okay, so now that we found both first prime, or the first derivative and second derivative graphs of f of t, now we got to determine the intervals at which the graph of f of t is decreasing, the intervals at which it's concave up, and the intervals at which it's slowing down. So in this case, for decreasing, we can just look at f of t and see where the slope of f of t is decreasing. Or we can just like look at this graph, because this graph is a representation of the slope of this graph right here. So as we can see, there is a decrease from -4 to 0, and then from negative, and then from 0 to negative, or from 0 to 2, there's also another decrease. So the decrease can be characterized by from -4 to 0, or no, not -4, because no, that is not correct, because the negative decrease starts right here, or the decrease starts right here. So it would actually start at -6, So it would decrease from -6 to -4, and also decrease from -4 all the way to +2. These should represent the decreasing intervals of the f of t graph. And then for concave up, we can just simply look at the first prime, or the prime of f of t graph. And so concave up, we can see that concave up is in two ways to say right over here. So we can say from -2 to from -4 to -2 right here, it's concave up, give or take. So from -4 to -2, and then it's also concave up from 0 to 2 as well. Yes, from 0 to 2 as well. Or we can just simply, or we can just say 0 to infinity at this point, because it goes past beyond 2. And then slowing down, this is a bit of a more interesting situation, because we have to take, what I like to do is create two number lines, and first number line is going to show first of f prime of t, and then the second one is going to show the double prime of f of t. And then in this case, we got to use the x-intercepts that we have in these problems. So for this one, the x-intercepts that we have are, or in the first prime, or first derivative, is -6, and we have -6 and 2, and then for f double prime, the x-intercepts that we have are -4 and 0. So it's probably a better way to write this. That. So I can just do -4 over here and 0 over here. Just clean this up a little bit just to make it look neater, just like that. So now we just gotta look at the patterns that we see over here. So right here we can say that up until -6, we say that this is negative, and then from -6 to +2 on the graph, on the first derivative of f of t, we can say that it's positive, and then on from 2 to beyond, not positive, it would be, no, because we want to look at the quadrants that the lines are present in. So actually in this case, instead of looking at the slope that we have over here, we could just look at the lines that are present on either the negative or the positive side. So in this case, from like infinity to -6, it is actually positive, and then from -6 to +2, it is negative, and then from +2 to infinity is just positive. And then now looking at the f double prime, so our x-intercepts are -4 and 0. So from -4 or from infinity, or negative infinity to -4, we can say that it is positive. And then from -4 to 0, sorry, my mistake. From negative infinity, again, we're looking at, instead of looking at the slope, you'd be looking at the line in which the graph is present. So in this case, it would be negative because it's in the negative quadrant, and then from negative infinity to negative 4, and then from negative 4 to 0, it would be in the positive